1989, a year that would go down in history as a turning point for science. Two esteemed researchers, Martin Fleischmann and Stanley Pons, made an announcement that sent shockwaves through the scientific community. They claimed to have achieved cold fusion, a nuclear reaction occurring at or near room temperature. This was a groundbreaking discovery, one that promised virtually limitless energy with minimal radiation and waste. But instead of being hailed as heroes, they were met with disbelief, ridicule, and even hostility. Cold fusion, if proven true, could revolutionize the world's energy production, drastically reducing our dependence on fossil fuels and nuclear power plants. Yet, despite its potential benefits, this scientific breakthrough has been shrouded in controversy for over 3 decades. Fleischmann and Pons were respected electrochemists from the University of Utah when they went public with their findings. Their experiment involved inserting palladium rods into heavy water, applying an electric current, and then observing the release of excess heat. They attributed this anomalous heat to a previously unknown form of nuclear fusion. The scientific community was stunned. Here were 2 reputable scientists claiming to have achieved something thought impossible, harnessing the power of the sun in a simple lab setup. However, skepticism quickly set in as other labs failed to reproduce their results. Critics pointed out flaws in their methodology and accused them of sloppy data interpretation. In the midst of growing criticism, the U.S. Department of Energy stepped in, organizing a review panel consisting of leading physicists and chemists. After thorough examination, the panel concluded that the Fleischmann-Pons experiment lacked credible evidence to support their claim of cold fusion. This official rejection marked the beginning of the end for cold fusion research. Despite this setback, some researchers continued pursuing cold fusion, driven by the allure of its transformative potential. Among them is Dr. Mitchell Swabach, who leads a small but dedicated team at the University of Missouri. They've developed a novel approach using laser-induced microexplosions to trigger nuclear reactions in metal deuterides. Although their work remains largely unrecognized by mainstream science, they continue to make strides towards understanding this enigmatic phenomenon. As we delve deeper into the mystery of cold fusion, we're left with more questions than answers. Was it a mistake to dismiss Fleischmann and Pons' discovery outright? Could there be merit in the persistent efforts of those still working on cold fusion today? Join us as we explore these unanswered questions and shine a light on the untold story of cold fusion. Cold fusion, a term that conjures up visions of limitless energy and revolutionary technology, or perhaps for some, the punchline of a scientific joke. The idea is simple. Harness the power released when hydrogen atoms are fused together, an event that in the sun's core produces our very own star's blazing light and heat. But instead of replicating the scorching temperatures found at the heart of our solar system, cold fusion proposes to achieve this feat at room temperature on a tabletop. Such a breakthrough would grant us virtually endless energy, clean and green, with no carbon emissions or radioactive waste. The story begins in 1989 when 2 esteemed electrochemists, Martin Fleischmann and Stanley Pons, made an astonishing announcement. They had achieved cold fusion in their laboratory at the University of Utah. The scientific community was left reeling. Never before had nuclear reactions been observed outside of well-controlled facilities like nuclear power plants or particle accelerators. Skepticism quickly mounted as laboratories worldwide attempted to reproduce their results without success. Critics pounced, accusing Fleischmann and Pons of shoddy experimentation and sloppy data interpretation. The scientific press joined the fray, labeling cold fusion a fiasco and the researchers' work pathological science. In just a matter of months, funding dried up and both scientists found their reputations in tatters. They returned to their native England, effectively exiled from the scientific community they once adorned. Despite this seemingly fatal blow, there remains a small but tenacious group of researchers who continue to pursue cold fusion. These dogged investigators, often working on shoestring budgets and dismissed by mainstream science, gather each year at the International Conference on Condensed Matter Nuclear Science to share their latest findings and exchange ideas. Among them is Dr. Pamela Boss, a nuclear physicist who leads a cold fusion research group at the University of Missouri. Defying her critics, she insists that there's more to the story than what met the public eye during the initial media frenzy. "I think it was premature to dismiss this field," she asserts. Dr. Boss points to recent advances in material science and nanotechnology as potential game-changers for cold fusion research. Another name that frequently arises in discussions of modern cold fusion is Dr. Bellew Entine. Mitchell Swartz, founder of Jet Energy Inc., a company dedicated to developing commercial applications for cold fusion technology. His Massachusetts-based lab has reported excess heat generation, a key indicator of nuclear reactions, consistent with those claimed by Fleischmann and Pons. These researchers are quick to emphasize that they're not peddling pseudoscience or chasing unicorns. Instead, they argue that cold fusion research occupies a gray area in the scientific process. Results are often inconsistent and difficult to reproduce, yet promising enough to merit further investigation. As we continue to grapple with climate change and our insatiable appetite for energy, one cannot help but wonder if history has been too hasty in dismissing cold fusion outright. Could this enigmatic phenomenon hold the key to a cleaner, brighter future? Or will it remain an intriguing curiosity, forever relegated to the annals of suppressed inventions and hidden science? In our next segment, we'll delve deeper into the challenges faced by cold fusion researchers and explore why this field continues to be shrouded in controversy and skepticism. Join us as we persist in unraveling this captivating scientific mystery. 1989 marked a pivotal moment in the history of science. Two esteemed electrochemists, Martin Fleischmann and Stanley Pons, made an announcement that sent shockwaves through the scientific community. They claimed to have achieved cold fusion, a nuclear reaction occurring at or near room temperature in a laboratory setting. The promise of this discovery was immense, virtually limitless, clean energy that could power homes and industries without the hazards associated with traditional nuclear reactors or fossil fuels. The experiment took place at the University of Utah, where Fleischmann and Pons subjected palladium electrodes to an electric current while submerged in heavy water. Deuterium, a stable isotope of hydrogen, would theoretically be absorbed into the palladium lattice, reaching critical density and triggering a nuclear fusion reaction. However, their declaration was met with disbelief and outright hostility from many quarters of the scientific world. Critics questioned the validity of their results, citing lack of clear evidence for the claimed excess heat production and nuclear products like tritium or neutrons, key signatures of a fusion reaction. In response to these criticisms, Fleischmann and Pons held a press conference hastily arranged just days after their initial announcement, hoping to quell the mounting skepticism. Unfortunately, this move only served to further alienate the scientific community as it bypassed peer review procedures, traditionally seen as the gold standard for validating research findings. By June of that same year, a review panel convened by the U.S. Department of Energy delivered a stinging rebuke, stating that the evidence provided was not sufficient to justify further research into cold fusion. This effectively ended official support and funding for cold fusion projects in major research institutions around the world. Yet, amidst this storm of controversy, there were some who stood by Fleischmann and Pons' claims. Researchers like Mitchell Schwartz, founder of Jet Energy Inc., continued to explore cold fusion, albeit under significantly reduced circumstances due to the stigma attached to the field. Over 3 decades later, the question remains, did Fleischmann and Pons truly discover cold fusion, or was it a premature announcement based on flawed data? Despite numerous subsequent experiments conducted by various researchers worldwide, no definitive answer has emerged. The controversy continues to simmer, fueled by occasional intriguing results that hint at possible breakthroughs, yet always fall short of indisputable proof. As we move forward, the allure of cold fusion remains potent. Its potential benefits, abundant clean energy, are too great to ignore. Yet, until clear, reproducible evidence is presented and accepted by the scientific community, cold fusion will remain an intriguing curiosity, forever relegated to the annals of suppressed inventions and hidden science. The quest for answers continues, shrouded in mystery and controversy, much like the science behind it. The story of cold fusion is a captivating tale that stretches back to the mid-1980s when two esteemed scientists, Martin Fleischmann and Stanley Pons, made an announcement that would shake the scientific community. On March 23, 1989, they claimed to have achieved excess heat generation through cold fusion, a nuclear reaction occurring at or near room temperature. This revelation promised a clean and virtually limitless energy source, potentially revolutionizing the world's energy production. Fleischmann, a British electrochemist, and Pons, an American chemist, were both respected figures in their fields. Fleischmann was a Fellow of the Royal Society, while Pons held a prominent position at the University of Utah. Their collaboration brought together extensive experience in electrochemistry, and they conducted their experiments at the university's Department of Physics. However, their groundbreaking claim was met with skepticism from the start, as other scientists struggled to reproduce their results. In June 1989, a review panel from the U.S. Department of Energy evaluated the state of cold fusion research and found it lacking in both theoretical underpinnings and experimental evidence. The panel concluded that the reported experiments were afflicted with significant errors and that the claim of excess heat production was unconvincing. The backlash against Fleischmann and Pons was swift and harsh. Their reputation took a severe hit, and their research funding dried up. Other researchers who had ventured into cold fusion faced similar consequences. Many lost their positions or were ostracized by their peers, effectively ending their scientific careers. The once promising field of cold fusion became a pariah in the world of science, leaving behind a trail of shattered dreams and unanswered questions. One of the most puzzling aspects of the cold fusion saga is that Fleischmann and Pons were not the first to report such results. In 1926, Greek physicist Andreas Papandreou claimed to have induced nuclear reactions in palladium at room temperature. Although his work was dismissed at the time, it predates Fleischmann and Pons's by more than 6 decades. Even today, the mystery surrounding cold fusion persists. A small but dedicated group of researchers continues to explore this controversial field, often self-funding their work or relying on private donors. Skepticism remains high within the scientific community, but some argue that a lack of funding and an unwillingness to entertain unconventional ideas have hindered progress in understanding cold fusion. The story of cold fusion serves as a cautionary tale for scientists and laypeople alike. The allure of paradigm-shifting discoveries can sometimes overshadow the rigorous demands of scientific inquiry, leading to premature conclusions and devastating consequences. Yet, the tantalizing possibility of clean, limitless energy continues to captivate our collective imagination, leaving many to wonder if cold fusion will one day emerge from the shadows of suppressed inventions and hidden science. The story of cold fusion is a labyrinthine tale of scientific intrigue, and at its murky heart lie two enigmatic figures, Martin Fleischmann and Stanley Pons. Born continents apart, Fleischmann in Czechoslovakia in 1927, Pons in the United States in 1943, their paths would eventually intertwine in a saga that shook the foundations of modern physics. Fleischmann was no stranger to groundbreaking research. A Fellow of the Royal Society and winner of numerous prestigious awards, he had made significant contributions to electrochemistry throughout his career. His counterpart, Pons, also boasted an impressive resume, having served as chair of the University of Utah's Department of Chemistry since 1982. In 1989, these two esteemed scientists announced they had achieved cold fusion, a nuclear reaction occurring at or near room temperature promising virtually limitless clean energy. The claim sent shockwaves through the scientific community, raising hopes of a revolutionary breakthrough that could solve global energy crises. However, their experiment was met with skepticism from the outset. Their announcement came without prior publication in a peer-reviewed journal, which is standard procedure for validating new scientific discoveries. Instead, they revealed their findings at a press conference, bypassing critical evaluation by experts in the field. Moreover, the experiment itself was shrouded in mystery. Its details were scant, leading many to question its legitimacy. Crucial data points were missing, and replication attempts failed across numerous laboratories worldwide. The scientific method, rigorous and meticulous, seemed abandoned in this race for immortality. Despite the mounting criticism, Fleischmann and Pons stood by their findings, even as their reputations began to unravel. Both men left academia under a cloud of controversy, their careers forever marred by the cold fusion debacle. Yet, the allure of cold fusion lingers, feeding off the desperation for a sustainable energy solution. Decades on, researchers continue to explore its potential, albeit cautiously and often under the radar. Is there something to this controversial theory, or was it just two brilliant minds caught up in the seductive mirage of paradigm-shifting discovery? As we delve deeper into the annals of The Lost Lab, one question haunts us. If cold fusion isn't the answer, what is? And who will dare to challenge the status quo, risking their career and credibility for a chance at revolutionizing science as we know it? The enigma of cold fusion remains unsolved, shrouded in doubt and controversy. Like an unfinished symphony, its melody lingers, teasing us with the promise of resolution just beyond our reach. But for now, the final note remains elusive, suspended in a chilling limbo where scientific rigor meets audacious ambition.